All right, this is the next method on our list, trapezoidal rule. So we're going to be doing the same thing we did with mid, left, and right, but now we're going to be doing trapezoids instead of rectangles. That's the only difference. This is just an intro problem. We're not going to actually find anything here. We're just going to set it up. So I've already got our graph here, and I've already got it cut into trapezoids. So the way it works is we've done 4 subintervals here, and so you can see each one has a width of 1. So this would be 1, 3, so 0, 1, 2, 3, and 4. So our delta x here would equal 1. But what we're doing now is we're taking that endpoint here and that endpoint here, and we're drawing a line between them to make a trapezoid. And then we go to the next one and draw a point, and we draw a line to make a trapezoid. And then, so all we're doing is taking endpoints of each subinterval and connecting them with a line. And that makes trapezoids on each. So to give you an idea of how that looks, I've already taken the first one here and I blew it up right here. And then we laid it on its side. So we know that when we draw these vertical lines, they're all parallel to each other, which is why it's becoming a trapezoid. You can see that is base 1, that's base 2, and they are parallel. And what this is right here is our height. And so area of a trapezoid is h over 2, base 1 plus base 2. And you can easily do that with geometry. It's just a quick little cut. But what we're going to do is label each of these and then transfer them over here. So this would be base 1. Doesn't really matter. It just means one of the bases, 2 of the bases. They're second base. First base, second base. It doesn't matter how you do it. And then this is our height of our trapezoid. So we end up with base 1 plus base 2 times h over 2. That's our formula. So now let's go back over here and see what they are. So base 1, well, that would be the height here of our trapezoid this direction. So what that is f of 0. That would be f of 0. And then base 2 here would be f of 1. And then the width would be our delta x, right? So if you look over here and we plug them in, base 1 is f sub 0, base 2 is f sub 1, and h is delta x. So we end up with delta x over 2 f sub 0 plus f sub 1. And I could just give you the formula and you could figure this out. You could just plug stuff into a formula, but you really want to think about how they are being created. And so that's just one of them. So now if I come over here and we do the same thing for each of them, watch what happens. So now obviously it's going to be delta x over 2, delta x over 2, delta x over 2, delta x over 2 for all of them. So that would just be delta x over 2, and then I will put a bracket here. So we know our first one was f of 0 plus f of 1. And then the next one is going to be the same beginning point right here. So if we go back to our picture, you can see f of 1 is used for this trapezoid, but f of 1 is also used for the second trapezoid. So this one would be plus f of 1 plus f of 2. So all we're doing is using our area of a trapezoid for each of them. So this would be delta x over 2 f of 0 plus f of 1 for this one. This would be delta x over 2 f of 1 plus f of 2. And then this one again will be moving on, and so it would be f of 2 plus f of 3. So these go here and here, here and here, here and here. And then so the last one would be f of 3 plus f of 4. So now if we put this together, a little bit of adding, we end up with f of 0 plus 2 f of 1s plus 2 f of 2s plus 2 f of 3s plus f of 4. And so that is where our area is coming from. So what's happening is when you look at each of these, when you draw your trapezoids, we're going to get 1 f of 0, but everything in the middle is going to be used twice. One for the one on the left, one for the one on the right, one for the one on the left, one for the one on the right, and so on. So at f of 3, we're going to use it for the trapezoid between 2 and 3, and we're also going to use it for the trapezoid between 3 and 4. But f of 4 is only used once. So this is where our formula comes from. We get delta x over 2, and then just 1, and then 2, 2, 2, 2, 2, and then 1 at the very end. So this would be our f of a, and this would be our f of b. And then everything in the middle gets 2. Okay, so it's just a bunch of trapezoids that we're creating. I hope that makes sense. And let's try one. So I've got our sign here, and we're going to do is cut this from 0 to 2. So let's do that first. 0 to 2. And where I got this graph was Desmos. You can click on the link and look at it as well, or you can just use your calculator. So we do the same thing we've always done. We plug in the function here. We go 0 to 2, and then zoom fit. And there's our graph. So it's a little bit higher here. You can see it right there. I went all the way to 3 on our picture, but just to 2. But that's our graph right there. And what's weird is I've already got 8 subintervals put in there because it's 0 to 2 with divided by 8. But let's figure out how this works. So again, we're going to take that entire interval from 0 to 2. So that would be 2 minus 0, which is 2. And we're going to cut it into 8 parts. So that's a fourth, or 0.25. So now if I take this and cut it into 8 parts, that would be 2. 4, I'm just cutting them in half, each of them, to get 8 parts. So I cut it in half, and then a half, and then each of them in half. So I get 1, 2, 3, 4, 5, 6, 7, 8, 7 lines to create it. That 8th one is there. So there's 8 parts, and we know each one has a width of 0.25. So all you'd have to do is what they're saying here is you take your 0 and you add 1.25, and then you take your 0 and you add 2 0.25s, and then 3 0.25s, and so on. Basically, you get 0.25, 0.5, 0.75, 1, perfect, 1.25, 1.5, 1.75, 2, and then that's it. That's our 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. Now, these are what we're plugging into our formula. So if you remember when we draw our trapezoids on here, that would be our first, because we're going from 0 to there, and then this would be our second, and then our third, and then our fourth, and then our fifth. We're just connecting endpoints. Oops, that's up here actually. And then there, and then that's it. So that's what our trapezoids are. So let's get a better picture with Desmos. So it looks like this, and you can kind of see the little connection of a line there, the trapezoids, but it's not. It's very, very close, which is good. We're going to get a decent approximation. You can actually see it here. Our trapezoidal rule gives us 1.40876, and we end up with 1.416 with the exact. So it's fairly close because of the end subinterval. So if I had cut it down to 4, it's not as good. See, so the more subintervals you get, the better the approximation. See, if I go off to 20, look at that. It's almost exact. You can actually see the number get closer as we do more subintervals. So let's go back to 8. Okay, so that's our picture. All right, and you can play with this. The link is there. All right, so now remember we're making little trapezoids, and we're just going to use that formula, either this one, where it's delta x over 2, and this, or you can just think about it, okay, well, we're going to get just that first point, and then use that one twice, that one twice, that one twice, and that one once. So our width here is 0.25, so we know it's going to be 0.25 over 2, because again, our area is h over 2, base 1 plus base 2. So now we know we're going to use the 0 once, and then 2 times everything else. So 2 f of 0.25 plus 2 f of 0.5 plus 2 f of 0.75, and we just keep going. And so I like to do 8 again. So just like I've told you this before, I like to do 4, and then we rewrite the next 4 down below to make sure I have it. So f of 1, and see we're starting again, plus 2 f of 1.25. It also helps to just keep track of where you are. See how everything lines up above and below? So just try to stay very organized with each of these. So we've got them all, right? And I'm missing 1. See? The last one is f of 2. So you may be thinking, oh, we only have 8 subintervals. Why do we have 9? Well, let's go back and look. So here we had 1, 2, 3, 4 subintervals. And when we write it, we end up with 1, 2, 3, 4, 5. So there's always one more than what we start with, than the number of intervals we have. And the reason is, again, we're using both of them to create our formula. So we're going to end up with all of them at the very, very end. So you should always end up with one more than the number of subintervals you have when you do these problems. All right, now we just need to input this in our calculator like we've done before. So I'm going to shrink to give room for the calculator. Okay, so again, we have sine x, and if you want the picture, the width is 0.25, so we get those nice 8 parts. So we know we could just go trace, 0, enter, and it spits out the number, or we can go to our table set. We start it at 0, because that's our first one we want, and the next one is 0.25 away, our distance there, perfect. And then we go to our table. And then now we can write all of these values down all the way to 2. So it would be 1 of those, 2 of those, 2 of those, 2 of those, 2, and so on, 2 of those, 2 of those, 2 of those, and then 1 of those. I might as well finish since I already started it. But what I want to use is just that, the variable again. So we're going to go second quit, and we're going to enter it exactly how it looks. So 0.25 divided by 2, parenthesis. And then we're going to go this, right, over to your variable, and then your function, and then we select yes, and then we do parenthesis 0, and then we move on to the next one. So plus 2, enter, enter, and you'll get pretty quick at this, 0.25, parenthesis, plus, and then you're going to just continue this, enter, enter, parenthesis, 0.5, I'm going to do it all the way up to 1, and then it's just going to be speed from there. I forgot the 2. So if you forget a number, just go back, second insert, 2, and then we continue on. So plus 2, scroll over, enter, enter, parenthesis, and the next number is 0.75. Parenthesis, and then just keep doing this all the way to the very, very end. You can fast forward, so I might as well just keep going. And then you kind of relax because you already know what the answer is when we look at the Desmos graph. I keep forgetting the 2. I don't want a decimal there. 2. It's a lot quicker than using a mouse to do this. So you're probably already done. Probably getting really quick already. Plus 2, and we're on to the last 2. Enter. Remember, y1 is where we set our y equals, so that's why it's showing up as y1. You can click on your y equals, and you'll see it's right there. I hit that second end. Takes me right back to where I was. 1.75 plus, and now we're on to our last one. Enter, enter, and then 2. Close the parenthesis. And we can go back and look at it at the end, but we get 1.40876. So 1.40876. And we use our cheat device. There it is, 1.40876. But again, you can always use your calculator with the math9 function to take the integral, and it'll tell you if you're close or not. So if we just evaluate the integral, you can see that it is 1.416. It's close. It's under what we're supposed to be getting. We can already see with our picture that it's under. So if you had something that was over, but your picture shows it's under, then you know you made a mistake. If this is like 2.5, of course you made a mistake. It should be fairly close if we have 8 subintervals on this small interval of 0 to 2. Now, always make sure, too, if you're not getting this answer, that you are in radians. So there we go. That is trapezoid rule.